So, sa previous video, I introduced yung formulas for the temperature, pressure, and density sa gradient region. So, ito ay for temperature at any height is equals to temperature at 0 kilometers or SSLC plus lapse rate times height. Na kung saan yung temperature or TH is also called ambient temperature. Now, pagdating naman sa pressure at any height, ito yung formula niya. And this pressure at any height is also called ambient pressure. And sa density, ganun din. This is the formula. And we're in for the density at any height is also called ambient density. So, for this formula here in temperature, ang height na tinutukoy dito will be called temperature altitude, wherein this temperature altitude corresponds to ambient temperature. Okay, so next, this one or HT. So this height here in pressure altitude or HP is also called pressure altitude, wherein this pressure altitude corresponds to ambient pressure. So, itong pressure altitude is merong device na ginagamit sa aircraft to measure pressure altitude, which is called altimeter. So, once na nakakita kayo ng altimeter na word or term sa problem, like for example, ang sabi, altimeter reads 15,000 feet. Ibig sabihin, this 15,000 feet na tinutukoy na to ay pressure altitude. Okay. Next, ay last tong height here sa formula ng density. This height is what we call density altitude, wherein density altitude also corresponds to ambient density. So, ibig sabihin lang nun, if you are given a pressure altitude, this pressure altitude is hindi po siya pwedeng gamitin here sa density, sa formula ng density. Also here sa formula ng temperature. So, for example, para mas maintindihan natin, I will give you an example. So, for example, a standard altimeter reads 4,500 meters when ambient temperature is 275 Kelvin. Determine the ambient pressure, the ambient density, the density altitude, and then the temperature altitude. Okay, so analyze the problem. First, given. Ano yung given natin? Given tayo ni analyze nyo muna. So, try nyo isipin ko ano yung given. So, ang sabi, altimeter reads. So, gaya nga na sinabi ko kanina, ang ginagawa ng altimeter, it measures the pressure altitude. So, altimeter measures pressure altitude. So, HP. Sabihin, itong nabasa na ni altimeter na 4,500 meters ay pressure altitude. So, we have pressure altitude na 4,500 meters. Next. Tapos, dun sa pressure altitude na yun, ang ambient temperature daw, or at that altitude, ang ambient temperature mo daw ay 275 Kelvin. Ambient temperature is denoted as TH. So, 275 Kelvin. Marami tayo ngayong required. First is yung ambient pressure or pH. Next is ambient density or raw H. Next is density altitude or H subscript raw. And last is temperature, altitude, or H subscript T. So, yan yung mga required. What will we do? So, first, analyze muna natin kung uniform ba yung mga units. So, ang given natin na pressure altitude and temperature altitude ay naka-metric, therefore, uniform na sila. So, hindi naman sila nagsabi na kailangan English unit yung sagot. So, magiging metric pa rin yung magiging answer natin. So, let's first solve yung letter A, which is yung pressure, altitude, ambient pressure. So, required, ayan. So, ayan na yung required. So, these are the required. Next, ay solution na tayo. So, burahin muna natin ito ang hindi kailangan. So, solution number 1. Solution for A. So, for A. So, first, ambient pressure. What will be the formula for ambient pressure? So, which of the two ang magiging formula natin? This one or this one? With this given. Ang magiging formula natin would be this one. Bakit? Dahil sa altimeter. So, yun nga, altimeter reads the pressure altitude. Therefore, sa pressure altitude, it corresponds to the ambient pressure. So, let's solve the ambient pressure. So, medyo tricky yun. First part pa lang, tricky na. So, let's solve na the ambient pressure. So, this will be the formula. Now, what is our pressure at 0 kilometers or SSLC? That in metric, which is 101.325 pascals. Next, what is our temperature at SSLC? It is 288.16 Kelvin. I will ask you if kaya nyo sagutan, go ahead. Pwede na kayo mauna and then i-skip nyo na lang itong part na to. Next ay, what will be your lapse rate? The metric one, which is yung negative 6.5 Kelvin over kilometer. And then, what is your pressure altitude? Pressure altitude mo is 4,500. So, para makancel yung kilometers, kailangan natin gawing kilometers to meters. So, times meters sa baba, kilometers sa taas. 1 kilometer is equivalent to 1,000 meters. Therefore, ang magiging kilometer mo ay 4.5 kilometer. Yun yung magiging pressure altitude mo. So, we'll write it here, 1.5 kilometers. And then, sa ilalim mo will be temperature at SSLC na 288.16 Kelvin. Okay, don't forget to add the exponent, which is 5.26. Now, so first one second. So, okay. So, first ay 101.325 times yung fraction na ano nangyari? 101.325 times fraction na 288.16 plus quantity negative 6.5 times 4.5 kilometers over 288.16 raised to 5.26. So, the answer will be 57,704. So, let's write it here sa taas. So, at nakuha na natin si ambient pressure, which is 57,704.0663. What will be our unit? Cancel si kilometer, magka-cancel si Kelvin dahil may Kelvin on both terms. So, ang tira ay Pascal. So, we have na the solution for ambient pressure. So, burahin na natin muna to para makuha natin si ambient density. Next, tayo ay P. Let's find the ambient density. So, what will be our formula? So, is this the formula or this one? Analyze ninyo. Neither of these two. Bakit? Dahil from this problem you are given is separate measurement for the pressure and temperature. So itong pressure altitude ay measure ng altimeter, and then ang nakuha na ambient temperature naman sa aircraft ay yung 275 Kelvin. There sa condition na yun. Therefore, we need to find the density at sa condition na kung saan meron kang 4,500 na pressure altitude and ambient temperature na 275 Kelvin. So, what will be your formula? Ibig sabihin, sa 4,500 meters, ang nakuha mo nga na pressure ay at that height ay this one, and then at that, and somehow at that sa may certain height ang and we know, and I want you to know that yung temperature altitude mo, yung pressure altitude mo, and yung density altitude mo are somehow not the same. Parang di sila equal. So, parang iba yung nami-measure na temperature altitude, iba yung nami-measure na pressure altitude, and iba yung density altitude mo. So, ang tanong, nung na-measure mo nga yung nung na-measure ng altimeter na 4,500 yung pressure altitude mo, na meron ka na ngayong ambient pressure, and meron ring device na ang na-measure ay doon sa condition na yon is ang temperature, ang ambient temperature mo is 275 Kelvin. Kailangan mo mahanap yung ambient density at that condition. So we have the pressure, we have the temperature. What we will now look for is your density at that condition. And what will be the formula? So we have to look back kung ano yung mga formulas na na-introduce ko sa inyo, maliban dun sa dalawang pinakita ko na we have to look back sa ibang formulas maliban dito sa binigay ko. Why again? Dahil itong for this formula, ang kailangan mo is yung density altitude. Pero given ka, nakuha mo yung at that condition, meron kang pressure, ambient pressure na ito 57,000, and at that condition, meron kang ambient temperature na 275 Kelvin. So, ang magiging formula mo, given ka ng pressure, given ka ng temperature, and hinahanapan ka ng density, all in the same condition, or at the same point, or point, kung ano man yan. So, ang magiging formula mo ay yung equation of state. So, diba tricky yung problem? Parang need mo talaga siyang analyze. So, let's see. Ang formula mo for ambient density would be isolate lang yung density, ilipat tong specific as constant to n temperature. So, magiging formula mo ay pH over specific as constant pH. So, this will be your formula. So, ligay na lang natin dito. So, your ambient density is equals to your ambient pressure, which is 57,060 Pascal, or Pascal is also, pag bin-breakdown siya, also ay magiging Newton per meter square over specific gas constant na in metric 287.08 joules or Newton meter kilogram Kelvin times temperature at that altitude na 275 Kelvin. Magka-cancel si Kelvin, magka-cancel si Newton, matitira si kilogram, meter squared, and meter. So, magiging density mo at that altitude or ambient density is 57,704.0363 divided by 287.08 times 275 will be this one, kilogram per meter cube. So, meron na tayong dalawa. Diba? Parang super tricky ng problem. Okay, next. Yan na, density, altitude. We have naman the ambient density, and this ambient density corresponds to this ambient density corresponds to the density altitude. Therefore, we can use the formula. So, we can use this formula or yung binigay ko sa inyo simplified formula kung saan naka-isolate tong density altitude, which is this one, TO over lambda, tapos large bracket na density H over density O raised to 1 over 4.26 minus 1. So, yan. Solve na natin ang density altitude, which is the temperature at SSLC. Yan. Kelvin over then substrate na negative 6.5 Kelvin over kilometers. Oh, parang di kasya. So, ambient density is 0.7309 over your SSLC density is 1.225 kilogram per meter cube, kilogram per meter cube raised to 1 over 4.26, and don't forget the minus 1. So, what will be our density altitude? So, just density altitude mode is 288.16 divided by negative, don't forget the negative sign, negative 6.5, and then 0.7309 na ambient density over 1.225 na SSLC density raised to 1 over 4.26 minus 1. Okay, what will be the answer? Your answer is 5. So your burahin natin to. C, or ambient density altitude will be 5.0612. And what will be your unit? Cancel si Kelvin, cancel si Kelvin, cancel si kilogram per meter cube, cancel si kilogram per meter cube. Ang natira ay si kilometer. So, this will be your density altitude. Now, last, what will be your temperature altitude? So, ang formula ng temperature altitude ay from this formula. So, ambient temperature is equals to temperature at SSLC plus lapse rate times height, or temperature altitude, or simply this TH minus TO over lapse rate. Therefore, and substitute natin yung mga given na 275 Kelvin and your temperature at SSLC na 288.16 Kelvin all over the lapse rate na negative 6.5 Kelvin over kilometer. So, magka-cancel si Kelvin, matitira si kilometer. So, therefore, your temperature altitude is 275 minus 288.16 over negative 6.5. This will be your temperature altitude. Parang ang laki ng discrepancy. Let's see. So, yan. 2.0246 kilometers. Now, dito nyo makikita kung gaano kalaki yung pinagkaiba ng iba't ibang altitude. So, first, diba, sinabi na given na ang pressure altitude mo is 4,500 meters or 4.5 kilometers. Then, pagdating naman sa density altitude mo, ang altitude mo ay 5. So, medyo malaki. 5 kilometers. And, sa temperature altitude mo naman, 2 lang. That's why, ganun ka-importante na ma-analyze mo muna yung problem dahil yan, magkakaiba yung altitude na tinutukoy dito. Depending dun sa kung anong quantity yung ginamit mo. Kung pressure, density, or temperature. So, yan. Nasa module activity niyan, kaya in-add ko na to, ang part na to. So, next. So, hinga-hinga muna. Okay. Our next topic, last topic na to for this module, ay the isometric region. So, yung formulas na introduce ko na TH is equals to TO plus yan, and then this one for TH. And then this one. These are all for gradient region. Na gradient region from 0 kilometers to 11 kilometers. Wherein your lapse rate is negative 6.5. Okay? And then your initial or your SSLC values are 101,325. Let's try this na nakametric lahat. And then temperature at SSLC is 288.16 Kelvin. And then yung density mo ay 1.225 kilogram over meter cube. These are all for gradient region. Pagdating naman sa isometric region, mag-iiba na yung formula natin. Why? Because dito nga sa isometric region, temperature does not change. So, tulad ng sinolve natin kanina, ay this isometric region ranges from 11 kilometers to 25 kilometers. Okay? Ay isometric. Bakit isometric? Isothermal. Sorry. Isothermal region. Isometric. So, yan. Isothermal region ranges from 11 to 25 kilometers. Now, this isothermal region has a temperature na 216.66 Kelvin. So, meaning, this temperature is from 11 to 25 kilometers. So, pag ang tinanong sa inyo, ano yung temperature sa 18 kilometers? What? Magsasolve ka pa ba? Hindi na. Dahil you know na 18 kilometers is in between 11 to 25. Therefore, same lang yung temperature na to 16.66. So, next. Pero, your pressure and your density is not constant. Temperature lang. Ito yung hindi naman lahat constant. So, only the temperature Actually, hindi naman talaga constant tong 216.66. Ano lang siya, super liit lang nung difference or super liit lang nung change ng temperature sa isothermal region. Kaya, kinonsider na constant siya na 216.66. Parang, kunyari, from 0, ito yung ground. Tapos, with respect to temperature. So, from 288.16, nung pumunta tayo sa 11 kilometers, ganyan yung slant niya. Pero nung nasa 11 kilometers tayo papunta sa 25 kilometers, parang super liit na ng discrepancy nila. So, ganyan. Pero meron pa ring change, pero super liit na lang. Kaya, consider na siya as constant temperature. Walang change. So, yan nga. Pagdating naman sa pressure, kung sa gradient region na 0 to 11 kilometers ang initial mo or nag-start ka sa SSLC, pagdating dito sa isothermal region, mag-start na yung pressure mo at 11 kilometers. So, kailangan alam mo yung pressure at 11 kilometers, which is na-solve natin sa last video na equal to 22,606.8233 pascals. So, kung gusto niyo malaman yung PSF niyan, convert na lang. Pero parang onti lang yung gagamitin natin mga constant. So, ito na lang yung alamin niyo. Marunong na rin naman kayo mag-convert. So, convert na lang to PSF if ever. Next ay yung density naman na nasolve rin natin kanina. Density at 11 kilometers is 0.3635 kilogram per meter cube. Again, this will be your initial values. Imbes na SSLC, this will be your initial values. And iba yung formula ng isothermal sa region. That will be, siyempre, constant na yung temperature. Wala na tayong formula for temperature. Dito sa pressure, may formula tayo. So, ang formula niya ay pressure at any height or yung height between 11 to 25 kilometers. Pressure pala. Over pressure at 11 kilometers. Bakit 11 kilometers? Dahil yan ay magiging initial mo for isothermal region. Hindi na po SSLC. Is equals to Euler's number or E. Kung makikita nyo yun sa cycle, ito siya. Shift and then this one. Yan na yung E. Yan. Okay, shift, ewan ko, LN. Basta yan. Euler's number raised to negative G or gravity over specific gas constant times height, which is in between 11 to 25 kilometers minus 11,000 meters. Take note that this height, okay, sulat natin. Hindi pala kita. So, this G, wherein yung G mo is gravity. Okay. So, ang gravity mo ay 9.81 meters per second squared. So, since naka meter to, kailangan metric yung gagamitin mong gravity dito. Okay? Okay. Now, yung R mo ay yung specific gas constant. Alam na natin yan. And then, this temperature is your temperature at 11 kilometers, which is 216.66. Last is your height na hinahanap is in meters. Hindi pala. Height na given yan, yung height is in meters. Para ma-minus sila. So, kunyari, ang tanong sa inyo ay 18 kilometers. Siyempre, gagawin nyo siyang meter. Kasi, pag minus mo yung 18 minus 11,000 meters. Super laki ng negative niyan. So, dapat gawin mo tong, hindi mo rin siya ma-minus kasi meters to. Ito naka-kilometers. So, kailangan i-convert mo muna to into meters. Okay? So, yan. In meters dapat yung height. And, okay. Yan. Also, pagdating naman sa density, same formula. Mag-iba lang tong nasa ilalim. So, kung ang formula ng pressure is E raised to negative GRT height minus 11,000 meters. Ang formula naman ng density ay same lang. Yan. So, ang pinagkaiba lang nila ito nasa ilalim. Which is constant, which are ito 22606 pag pressure and 0.3635 for density. Anyway, let's try this. Let's try to solve a problem using these formulas. So, sinulat ko na dito yung mga important for isothermal region. Siyempre, ang isothermal region ay from height na 11 to 25 kilometers. So, your temperature from 11 to 25 kilometers will always be 216.66. Your initial, dahil start na tayo for isothermal region, start tayo from 11 kilometers, kailangan natin mahanap yung pressure at 11 kilometers, which is, ito na, to 22,606 pascals, and your density na 0.3635 kilogram per meter cube na at 11 kilometers. So, since same lang naman yung formula, ginanyan ko na lang. So, kunyari, hangahanapin mo yung pH, takpan mo na lang ito. That will be your formula. And then, if you're looking for your density at height within 11 to 25 kilometers, this will be your formula. Takpan mo na lang. Okay, let's try to solve this one. What will be your pressure and the find the temperature, pressure, density at 15 kilometers. Okay, first analyze the problem. 15 kilometers. 15 kilometers ay nasaan na? Region or isothermal region? So, isothermal region na siya. So, first, analyze na natin yung problem. Nakuha natin na ang height niya is 15 kilometers, which is in isothermal region. Therefore, isothermal region, therefore, meron ka ng temperature. Temperature is 216.66 kilometers for 11 to 25 kilometers. Okay, and then your required are temperature, pressure, and density at 15 kilometers. So, solution. You don't have to solve the temperature. Just put, dahil equal lang naman sila, so this one. So, lagyan na natin T15. This will be your temperature. At next ay yung pressure. So, burahin muna natin. Paano ba? Anyways, this will be your temperature. Next ay yung pressure at 15 kilometers, which is isothermal. Therefore, ang gagamitin natin formula, this one. Takpan lang natin to. So, we have pH over P11 is equals to E raised to negative G over RT times height minus 11,000 meters. Again, kailangan yung height mo ay same unit here na meters. So, kailangan gawin natin itong meters yung 15 kilometers. So, magiging 15,000 kilometers. Okay. Now, let's solve. So, pH, ililipat lang natin si P11 times E raised to negative G over RT H. Naka-raise yan, ha? So, yan. So, let's insert na the values. So, what is your pressure at 11 kilometers? 22,606.8233. Hindi ata kasya. Pascals times. Lagyan na lang natin dito sa ilalim. Okay. Times E raised to negative G, which is naka-metric to. So, gagamitin natin gravity is naka-metric, which is negative E raised nakadikita. Yan. 9.81 meters per second squared over what is your R? Metric, 287.08 Newton meter over kilogram Kelvin. Kita pa ba? May naiintindihan pa naman. Times your temperature na 216.66 Kelvin, and then times height na 15,000 minus na kagad natin 15,000 dahil hindi na kasya. 15,000 minus 11,000 which will be 4,000 meters. So that will be our formula. So magkadugtong to, times 22,606 times your E. Now let's solve this. So pH mo is equal to cancellation of units. We have here Kelvin, cancel. Kita ba? Okay. We have here the parang may kulang. Anyways, meters here, cancel. And then, kapag nireciprocal, maging meters per second squared times reciprocal ng kg over Newton. Kita ba? Ay, hindi ko nakikita. Ayan, kg over Newton. We're in kg times meter per second squared, or ito is equal to Newton, so magka-cancel. Therefore, wala kang unit here sa part na to. Wala ka ng unit here. Ang magiging unit mo is ito. Kung anong unit na ito, which is Pascal. So, burahin na natin. Ay, wag burahin. Hindi pala natin buburahin. Kailangan pala isolve. So, ito lang pala. Pascal. Ay, mahulog. So 22,606.8233 times your E na shift ln, your E raised to fraction na negative 9.81 over your R na 287.08, okay pa naman, times your temperature na 216.66, and then lipat tayo na 4,000 meters. So, let's see kung lalabas yung sagot. There you go. Your pressure will be 12,029.6082 pascals. So, pressure mo daw at 15 kilometers. Yan. So, that will be your pressure at 15 kilometers. Let's solve naman yung density at 15 kilometers. Meron na tayong temperature and meron na tayong pressure sa 15 kilometers. Now, last, hanapin na natin yung density at 15 kilometers with this formula na, so takpan lang natin to. So, density at any height over or height between 11 to 25 kilometers over density at 11 kilometers is equals to E raised to negative G over RT times height minus 11,000 meters. Kung na-save nyo yung in-input natin kanina sa cycle, actually, pwede nyo nang hindi burahin yung part na to. Palitan nyo na lang yung anyway, sulat ko na lang. Magiging ganyan, diba? Times so, eto nasa part na to, kahit hindi nyo to baguhin it's the same lang naman. Eto na lang yung babaguhin ninyo. So, anyway, nabura ko na siya at na-delete ko na yung nasa cycle. Sulat ko na lang. So, density mo at 11 kilometers is 3635. No, naghihingalo na ang aking pentel pen. Okay, kilogram per meter cube times your E. So, sa ilalim na lang ulit natin. Again, E raised to negative G na 9.81 dahil naka-metric. R na 287.08 and Newton meter over kilogram Kelvin times your temperature, which is constant na 216.66, and less your so 15,000 minus 11,000 ulit, kaya naging 4,000 meters para hindi na natin para hindi na tayo patagal. So 0.3635 times the E raised to negative 9.81 over 287.08 times 216.66 times kahit pagtabihin nyo na ito 9.81 and this one, parehas lang naman silang times, so try natin magkatabi. 4,000 and then add the last quantity. The answer will be, hindi nyo nga ito nakakita. So yan, your density at 15 kilometers is equals to 0.1934 kilogram per meter cube, dahil nga cancel naman lahat na ng units here. Matitira na lang ay kilogram per meter cube. Okay, another 1 hour pala yun. So if ever na i-require kayo, kunyari pressure nyo daw at 15 and pressure nyo daw na dapat naka-English or PSF, or density nyo na naka-PSF or slugs per meter cube, then ang given sa inyo na height ay kunyari height at 40,000 feet, imbes na mag-convert kayo ng mga gravity convert nyo pa into feet per second squared, or yung temperature na 216.66 Kelvin. Diba? Ito yung gravity, gagawin nyo pang feet per second squared, or yung R, gagawin nyo pang 1716, or yung temperature, gagawin nyo pa tong degree Rankine. Hindi nyo na kailangan gawin yon. Ang gawin nyo na lang is i-convert tong feet lang into meters. Gawin yung feet to meters. Okay? So, pag naging meters na siya, pwede nyo siyang i-input dito sa formula. Then, meron ka ng meters, diba? And, if nire-require ka ng PSF na lang ang gamitin mong pressure at 11 kilometers. So, imbes na i-convert mo pa itong 1, 2, 3, 4, 5. So, ang dami nyo i-convert. Magiging dalawa na lang i-convert mo. This feet, etong feet, gagawin nyo lang yung height na feet to meters para mailagay mo siya dito. And itong pressure at 11 kilometers. So, madali na lang naman yan. So, times ano lang yan. 101.325 sa ilalim for pascals na makancel. And 2116.8. Yan, nakukuha mo na yung pressure at 11 kilometers. And times mo na lang dito. Yun. Mas madali na lang siya. Same goes pagdating sa density. Yun nga, kinonvert mo na yung 40,000 feet to meters. And then, itong density at 11 kilometers na 0.3635, i-convert mo na lang to slugs per feet cube divided by kilogram per meter cube. Yung value nun ng air. So, yan. Para hindi na kayo mapadali. Ay, mahirapan. Anyways, nakakapagod na. So, kaya na yan. If ever na may question pa kayo, ask lang po kayo sa akin through Discord. And I'm sorry kung na-delay po itong video na to. Dahil po, ihirap po talaga edit or gumawa ng video. So, parang 1 to 2 hours akong nagre-record dahil, syempre, kung nakikita nyo na 1 hour yung video, syempre, nag-i-stop pa ako dahil umiinom ako ng tubig or nagsusulat ako. So, inaabot minsan ng 2 hours. Then, since cellphone ko lang naman ang gamit ko, doon na rin ako nag-e-edit. Ang bagal mag-import and export import and export ng video, inaabot ako ng 2 to 3 hours dahil cellphone lang siguro gamit ko, kaya ganun. Or dahil malaki rin yung MB kapag 1 hour yung video, parang 8 GB ata yan. And after nun, syempre mag-upload pa ako sa YouTube. Etong pag-upload sa YouTube, madali na lang more on 1 hour lang yan. So, yun. Thank you sa pag-intindi, and I hope nasagutan niyo po yung mga module activities and then quiz and then exam, dahil feeling ko naman mas madali na yung exam and quizzes compared dun sa module activities. So, good luck and thank you. Bye.